Hi everyone, sorry if you couldn't make the live lesson we did this morning, and I was not able to record that because it said it was going to kick a couple people out of that, so I figured that was not fair to do to them. So I'm just going to reteach it real quick right now, and we'll see what we can do with that going forward. Okay, so resonance, before we even get to that, a couple things that people are having mistakes with that I've noticed a lot with Lewis structures. First of all, hydrogen can only have one line. It can only have 2 electrons. So it can't be in the middle, and it can't get dots. All it gets is one line of something else, and that's it. Second, you have to use the number of electrons that you have, whether that is however many you count up without a charge, or if you have polyatomic with adding the charge. It's like if mom gives you $30 to go to the mall. You can't spend more than $30 if you only have $30, and if mom's going to ask for change back, you spend all of it because you don't want to return money if you don't have to, right? So if you have 24 electrons, use 24 electrons, okay? And we only use double and triple bonds if we have to use double and triple bonds. Don't just start with them. Use them if you run out of electrons. Otherwise, it makes it harder because then you try to figure out what am I going to do with all these extra electrons. And then you must use brackets of polyatomic ion. Yeah, those are the main things. Okay, so what resonance means is if we have structure, so let's take NO3, nitrate. Okay, so NO3, we have 1 N and 3 O's with a -1 charge. So O is 6, 6 times 3 is 18, plus 1 is 19, plus 5 is 24. Okay, so we have 24. So I have my N and my 3 O's. Okay, so I have 24 electrons to use. I've already used 6 of them, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. The O's are all happy, the N is not, so I'm going to pick an O, take away 2 electrons, make a double bond. Now what resonance says is, how do we know which one of these bonds it could be? It could be any of them. So far we have to use a double-sided arrow to show that it could be any. So I'm going to draw another version of it. So let me do my basic NO3. I'm going to put my double bond over here. And the easy way to see this is basically wherever you move it, you're saying, oh, the other 2 are going to resemble the other 2 up here. Okay, and then I will have one more structure. I'm going to make it just a little higher so it's easier to see. And now my double bond will be over here. Okay, and of course, since they're polyatomic ions, I have to put my brackets for each. Okay, let's try SO2 over here. So I have 1 S and 2 O's. S goes in the middle, my 2 O's. Okay, all of those happen to be 6, so 6 times 3 equals 18. So I have 2, 4, 6, 8, 10. Remember, we always start with the outside atoms. 12, 14, 16, 18. Now S isn't happy, it's only got 2, 4, 6. I'm just going to happen to take the right side, I'm going to make a double bond. Okay, but since it could also be the other one too, I have to put that double-sided arrow, and I have to say I have S double arrow here. Essentially, I'm just flipping this thing in space. Oops, sorry, I did the same one again. Okay, I don't need brackets, not a polyatomic ion. O3 will be very similar. I'm going to have O, O, and O. They never form a triangle. It's very unsustainable because that's a very tight angle to try to hold everything. Because remember, electrons want space. Okay, so I'm going to have 18 total. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, let's do the left-hand side first, this one. Okay. Since it could be either, I need to draw my resonance structure. Okay, and that's how you do resonance structures. If you have any questions, please shoot me an email. And for the lesson tomorrow, if you can join us, great. And if you can't, that's fine too. I'll try to see if I can get the recording going without booting anybody out. Or else I'll make another video after like this. Okay, everyone have a wonderful day. Bye.